Another thing we can use the ideal gas law to do is to calculate the density of a gas. Now, when we're talking about densities of a gas, the density of a gas is usually going to be asked to do grams and liters. Now, how this fits into the ideal gas law is remember that the volume has to be in liters. Another bit of information we need to remember is that the molar mass of a gas is equal to grams per mole. And this is the ideal gas law. Now again, we're going to develop an equation to calculate density using the ideal gas law by making some substitutions. So I can rearrange this law, the second law here for molar mass, as N equals G times, divided by M. And I'm going to plug this one into the ideal gas law. So I get PV equals GRT over M. Now, you might recall that I need to have G over V to have density. See over here? Density is G over V. So I'm going to rearrange this equation, the ideal gas law, and I'm going to bring the volume over. So don't worry about it too much yet. I'm just going to say P equals GRT divided by V over M. So don't worry about this too much, except look right here. I have G over V. Well, that is what density is. So I can substitute in, and I could say that then I could say P equals density times RT over M. So let's rearrange for density. So I need to get M, so M's on the denominator, so I'll multiply it over. So it'll be P times M equals D times RT. And then rearrange, I get D equals P, which is pressure, times the molar mass, divided by RT. So if I can rearrange the ideal gas law, I can find an equation for density. So I'm going to rewrite that over here. So density equals pressure times the molar mass over R times T. So the problem I want to look at is 10.75 in the back of your textbook. And let's record the information that they've given us. It asks, what is the density in grams per liter does oxygen have? So we know it's O2, so the molar mass is going to be 16 times 2, because I have 2 oxygen, so that is 32 grams per mole. And it says that it has, the temperature is 24 degrees Celsius, which is going to be, what is that? Plus, we need to add 273, so that is 297 Kelvin. And it has a pressure of 742 torr. So we'll calculate, turn that into atmospheres. Anytime you're using the ideal gas law, you're going to have to use liters and atmospheres because of the gas constant. So now let me plug it in. So D equals the pressure. And remember, I have been doing the pressure conversion inside the problem only because I have found that it gives me closer answers to what's in the back of the book. So there's the pressure, and then the molar mass for oxygen is 32. And I'll divide this by R, which is the gas constant. That's always the same. and then multiplying it by T. And when I solve this problem, I get that the density of oxygen at this pressure and temperature is 1.28 grams per liter. So that's the density of oxygen at the given pressure and temperature. Again, another way to use the ideal gas law.